Now we'll see the last concept in TCP, that is TCP timers. So TCP uses various timers to operate properly. One of them is retransmission timer. So why we use retransmission timer? To retransmit the packet. So this is a question always TCP has. TCP is sending some window, correct? That window is fixed by congestion size and receiver window size. So forget about that. So TCP is having this problem. TCP has a window. It is sending all the packets in the window. But sometimes what happens, because of the problem in network, some of the packets may be lost, and otherwise some of the acknowledgement from your receiver will be lost. So how this sender is going to know that some packet is really received by the receiver or not, right? This is always the question. So to answer that question, so your TCP is going to maintain a timer, that is retransmission timer. So whenever that retransmission timer is times out, then immediately the first packet in the queue which is not acknowledged will be resent. Okay, so in that way, so this retransmission timer is going to be useful. We will see how this retransmission timer will be, its value will be fixed, how to fix it. Okay, so generally for that we have to calculate round trip time. Okay, based on the round trip time we are going to decide. Why? Actually, this is your sender, this is receiver. In hypothetical situation, when sender sends a packet, okay, then eventually receiver will receive it, then your acknowledgement will come back in a hypothetical and best situation, right? Forget about all the network delays, everything. Then we can say that within round trip time of time, RTD time, you should get the acknowledgement. But in the reality what happens, there are a lot of routers in between your trip, in that they will be causing some delay, correct? Sometimes your packets will take a complicated route. We don't know exactly how much time they will take to transfer the data from here to here, correct? That's why I want to say that in the reality calculating round trip time is a difficult task, right? But that's why how TCP is going to calculate round trip time. Once we compute the round trip time, then we can keep the retransmission timer based on this value. Example, let's say we'll ask God, please tell us what is exact round trip time. What is round trip time here? It is nothing but when a sender sends a packet, it will go through this network and it will reach the destination. After that destination will send a packet, it will go through lot of routers and they will process it. The entire thing is nothing but round trip time. Let's say that is 1 minute. Really we know that it is 1 minute. Then what we can do? Then we can keep retransmission timer around 1 minute, maybe 2 minutes or 3 minutes, correct? So that's why calculating round trip time is important for us, but exact round trip time is difficult to calculate because that is dynamic, that will change. Example, first of all, let's say you send a packet, it will come back. If it comes after 1 minute, then you think that 1 minute is the round trip time. But what happens after some time? So that will be changed to 2 minutes. Why? Because some routers may take a lot of time. Then you think that there is a 2 minute delay. Then after that it will become 4 minutes because multiple routers take a lot of time. Then when you finally fix your value to 4 minutes, that is round trip time, then what happens is suddenly some routers will perform very fast and quickly they send the data. This time within 30 minutes, within half minute, okay, you get the data back. Then in that way your round trip time is going to be highly variable. We can't predict it, understand? So that's why what we do is we continuously predict it. How to predict round trip time value at this moment? Okay, that is one thing very important. I will teach you that. Okay, will at this moment let's postpone that. Somehow we have to find out round trip time. Based on that we are going to fix the retransmission timer. That is important. That's why let me postpone it. Now remaining timers are very easy to understand, and there is no big story about that. Persistence timer. So what is persistence timer is, here sender is going to maintain one timer that is called persistence timer, and initially that will be around 30 seconds or something. This number is not important, just for example I am giving it. Then whenever receiver sends a packet saying that there is no space, like 0, then immediately when it is received by sender, sender is going to maintain a persistence timer. He will on that persistence timer. After 30 seconds if he doesn't get any information from receiver saying that there is a space, then this will become timeout. Then we will be sending a packet called probe packet. The purpose of probe packet is just to alert the receiver, that to ask the status of the receiver. My dear receiver, I did not hear from you so long. What's the matter? You have anything? You have any space? Please let us know. Then receiver is going to send the acknowledgement one more time. Okay, that is one thing. Second thing, sir, after sending the probe, okay, this receiver doesn't respond. What you do? Simple. Then after some time, so there will be one more probe we send. In that way, to send the probe also, we start this persistence timer again. That means first time when we send the probe, at that time again we on the persistence timer, but we double it. Initially we took 30 seconds, right? We take this time 60 seconds. In that way, so after 60 seconds, what happens? Example, let's say you send ACK1, right? Sorry, probe number 1, right? For probe number 1 there is no response. Then after 60 seconds we send probe number 2. If there is no response, we send probe number 3 for periodical intervals, and we double the timer. Okay, now let me tell you with one example what is going to happen. Clearly we'll see. Sender, receiver. Receiver sent a packet saying that the size of the receiver window is 0. Sender will understand and he will keep quiet. After some time, but immediately he will maintain a persistence timer. Assume that, let's say, persistent timer is at this moment 5 seconds. Okay, so after 5 seconds he is going to send a probe packet. That is the way there will be an agreement. What happened actually, after 2 seconds this receiver's window become empty or free. Then he sent an advertisement saying that we have 50 bytes of space, my dear sender, please send. Okay, but what happened? That is lost. Don't worry, now there is no problem, because after 5 seconds we are going to probe, right? Then after 5 seconds here we send a probe packet, probe number 1, saying that what is the status, Mr. Receiver. Assume that, let's say, receiver is busy, he did not respond. It is not compulsory to respond actually. So if receiver don't respond, what is going to happen? Then we are going to, after 5 seconds we sent a probe packet, right? This time persistence timer will be doubled, 10 seconds. That means after 10 seconds we are going to send another probe, probe number 2. Then after that, while keeping sending probe number 2, we create one more persistent timer with 20 seconds. Then after 20 seconds another probe. In that way probes will be sent. First for 5 seconds, after the 10 seconds, 20 seconds, there will be a limit of course. Then usually after 60 seconds, after sending lot of probes, then for every 60 seconds, this is the maximum limit. Okay, then after that what you do, sir? For every 60 seconds we continuously send probes, probe for every 60 seconds. Then eventually at some point of time, really the receiver has a space, he will send the acknowledgement that will be received by you at some point of time. At that time we will continue our normal operation. So this is about persistence timer, and remembering the idea is enough. Okay, not exact details like what is the timer value, after how many times we send the probe, that is not really required. Now keep alive timer. What is keep alive timer is, let's say this is sender, this is receiver. Okay, assume, let's say it is a client server model. So who is client generally? Who initially initiates the connection by saying that I want a connection? That is called active open. That is, that process is called client. Okay, let's say client and server. What happened? Client opened a connection, server said okay, for that we know the TCP connection establishment. After that, let's say client is not sending any data, he is not requesting any data. Then now you are afraid, server is afraid that client is disconnected. That means there is a problem at client side. For that, what this server will do is, otherwise, sir, what is the problem for server? What happens if client doesn't send anything? What happens if client is idle? If client is idle for a lot of time, then unnecessarily server is wasting his resources. Maintaining the connection takes some buffers, everything, right? That's why server is afraid of that. That's why, so what he will do is, usually for after 2 hours there will be a timer. That's why server maintains a keep alive timer. Okay, So after 2 hours, server will send a packet saying that, my dear client, are you there? Okay. Then if client responds, okay. Otherwise, we send one more time in that way. Okay. So after some time, we realize that really client is not available. If client won't respond for this one, we close the connection. In that way, so keep alive timer can be used. So we use keep alive timer generally to check whether this connection is really, they are valid or not. That means the other end is dead or alive. That's why it is keep alive timer. Okay. What is time wait timer? So time wait timer is nothing but it is related to time wait state. Did you remember in TCP connection establishment I taught you time wait state. After that we go to closed, correct? Generally this is, we wait for some time to move from time wait to closed. To close the connection we have to wait because whatever the segments related to this current connection they should die. For that they take some time, right? So that time is generally called maximum segment lifetime. Okay, that is related to time to live in network layer. That means we know that how long it will take a packet to alive, right? After some time every packet is going to be dead. So the time is something, let's say, will be calculated by designers. Don't worry about it. Usually typically that values are 30 seconds, otherwise 1 minute, in that way. Okay, so after that every segment is going to be discarded by the network. So that's why if you wait for two maximum, generally what happens is, so there will be a timer, that is time wait timer, that will be initialized to two maximum segment lifetimes. So we wait for exactly two maximum segment lifetimes. Before that every segment will be dead, so that when you start a new connection the old segments will not disturb you. That's why, so this timer will be used, which is time wait timer. Now we covered all the timers. We have to see now how this retransmission timer will be fixed. Okay. For that there is a big story. We will see how generally that will be calculated. Okay. Now we'll see retransmission timer, how it works. Okay. Also known as RTO. So how we fix RTO? Before seeing that, first of all we just summarize about this retransmission timer, how you use it. Example, this is your set of packets P1, P2, P3, P4, P5 in the window which are not acknowledged so far. But let's say you already sent P1, P2, P3. While sending P1, immediately open one timer. Okay, there will be only one timer, retransmission timer, RTO. So let's say the timer's value at this moment is 30 seconds. It is going to time out after 30 seconds. Before that, let's say acknowledgement comes saying that I got up to 3, ACK3, ACK4. That means I got up to P1, P2, P3. Then immediately we stop this timer and we purge this P1, P2, P3. Okay, then we start the timer again and we continue sending the remaining packets. Okay, now again one more valid acknowledgement comes. You know what is valid acknowledgement, correct? So whenever a valid acknowledgement comes, then restart the timer. Okay, that is the way we use the timer. Second thing, sir, what if you don't get the valid acknowledgement within the timers whenever before timer times out? We will see what happens. Example, let's say you sent P1, P2, P3, everything, and you started timer with 30 seconds. So far you sent lot of packets according to the rules, but you did not get any acknowledgement. Then this timer will become expired, right? So this will say 0 seconds after some time. When timer times out, what you do is the question. Simple. Take the first packet and send it. So whenever timer times out, we do the retransmission. That's it. Okay, not more than that. This is about this retransmission timer and its uses. So now how to calculate it is important. How to fix it exactly, it is related to round trip time. Based on the round trip time, this timer we are going to fix. First of all, we'll see how to calculate round trip time. It is complex thing, right? And it is involved thing. That means you have these various various routers in between, right? This is your sender, this is your receiver. We do not know exactly how much time exactly that transition takes, right? That means the packet has to go from here to here and it should come back. So we don't know exact path. We don't know how much time exactly it will take everything. So we are going to guess round trip time first. So how we are going to guess round trip time, we will see. Now we'll see how to guess this round trip time because it is highly variable. Why it is highly variable, we'll try to understand. This is, let's say, sender, this is receiver, and you send a packet. This is your network. So network's behavior is highly variable, correct? It depends on the router and its behavior. So that's why there are a lot of routers. Each router takes variable amount of time to process your packet. That's why, so one time, let's say when you send a packet, it may take 1 hour of time, just for understanding the thing. Then sometimes it takes 2 hours of time, then maybe 3 hours, sometimes only 5 minutes when there is no traffic, right? So now what I want to say is this round trip time is not a fixed value, it is a variable. Then we have to tune ourselves to the current round trip time. Okay, when you don't tune yourself to current round trip time, what is going to happen, I will tell you. Example, let's say you observed only this value, one value. You sent a packet, but within 5 minutes, let's say you got acknowledgement, then you realize that network, the round trip time is 5 minutes. Okay, now you fix this timer to exactly 5 minutes or more or less, maybe 5 to 7 minutes or something. When you do that, then what is going to happen? After this calculation, network congestion become very high. That means your network become busy. Then you are sending a packet, and after 5 minutes automatically, though your packet is alive, it is not dead, but still you are guessing wrongly, you see, because when you calculated round trip time, it was 5 minutes, but now current traffic is 15 minutes. That means packet takes at least 15 minutes, and your acknowledgement takes at least 15 minutes to come back. Then, but your 5 minute, I mean, your timer will be timed out very quickly, and you send that packet again and again and again. Are you not adding congestion? Yes, definitely. We are adding more congestion to the network. That's why fixing 5 minutes when traffic is 15 minutes is definitely a wrong thing. Don't do that. But sir, why don't you fix 15 minutes? But I don't know at that time when I calculated. If I fix 15 minutes, suddenly that might become 2 hours. Then again this 15 minutes also will be same kind of thing like 5 minutes. Sir, we do one thing. We observe for half an hour. We switch on our computers and we observe first 100 packets. Okay, if you observe first 100 packets, then on that what you do? Let's take maximum delay, sir, 2 hours. If you take 2 hours, what is going to happen? You see. After that, network may become very free, and you are getting acknowledgements only for 5 minutes, but your timer is 2 hours. Okay, then if you keep a long timer like this, which is not really required, but within 5-10 minutes you are getting acknowledgements, then see the story. So here, let's say you sent a packet that is immediately lost. Now your receiver is waiting for that packet, but you did not send it. When will you send it? After your timer times out, correct? Then after 2 hours you are going to send it. Then receiver will face a lot of delay. He will wait for the 2 hours, correct? Is it good? No. So this is also not good. That's why fixing it to 2 hours, fixing it to 5 minutes too early, everything is wrong. Then what should be the right thing? The right thing should be guessing exact thing, right? So that's why. One more analogy I give. Example, let's say you're staying in city like Delhi. So you want to, guess some time. Example, let's say your brother is going to this place, let's say receiver. So let's say you're sending one of your brother to your relative house. Let's say Raju. Let's say your relative is Rani. We are sending Rakesh to Rani's house. Rakesh has to give a parcel, okay, some gift box to Rani, and he has to come back. So for up to that point of time you want to wait, okay, but you don't know how much time he will take. It depends on the traffic. Sometimes it takes 3 hours, sometimes it takes 4 hours, sometimes it takes 1 hour, in that way. If you don't know exact value, example, if you know exact current trend, otherwise current traffic, example, you exactly know current traffic that in that it takes 2 hours of time, then by that time you can go to movie and you can watch that movie for 2 hours. Then if you come out from the theater, then Rakesh will come and you can do the remaining thing, whatever you wanted to do, right, rather than waiting. But you don't have current information. 50 years back what happened, the information 50 years back actually there was no traffic. Then Within 1 minute of time we could have reached Rani. That's why you remember that old data, only 1 minute, the best data you have. Okay, that means not best data, that means you have data which is very old data. Then at that time the data says that only 1 minute of time it will take. Then you wait for Rakesh for only 1 minute of time, he will not come, he will take definitely 2 hours, because that is actual current delay, that is highly variable, right? At this moment it is actually 2 hours. Then if you think that it is only 1 minute, then definitely there is a problem. Why unnecessarily you have to wait for 2 hours? You would have gone to movie, right, by that time. So, and second one, taking another wrong information. In one particular day what happened, so in same incident Rakesh took 5 hours to go to Rani's house and to come back. But that was very rare event. At that time his bike got, I can say, breakdown. Okay, and that's why he spent 5 hours of time. But if you follow that, what is going to happen? You see, you thought Rakesh will come back after 5 hours, that's why you went to some shopping without informing him. Then Rakesh will go and he will come back, but he takes only 15 minutes, because the 5 hours is your guess, that was again a wrong guess. Correct, it is not really reflecting the current traffic. That is the reason I can say, finally, if your value what you are guessing does not reflect the original traffic, then you will be suffering, right? Already I told you two examples. One is either receiver will wait for your packets, second one maybe you are unnecessarily retransmitting. So sir, then how to guess correctly? We are not gods, right, so that we can guess exactly? Yes, but at least we have to tune ourselves. How to tune ourselves, I will tell you. So finally the story is like this: we have to tune ourselves by using a variable called round trip time smooth. So this round trip time smooth is nothing but which is the summary of all the previous history. Okay, now, but sir, how you maintain it? I will tell you how to calculate this value, which is nothing but summary. Finally, every time you are going to get a new value, that is RTTM. What is this RTTM? I will tell you. At this moment, when you send a packet, you got the acknowledgement after 1 hour, then we say that that is a current RTT, also known as RTT measured. So we are going to use the current RTT, and we are going to use the previous history, and we are going to compute the new summary. So the formula for new summary, currently how to understand the traffic is RTTS equal to, we are going to use some weightage to old value and new value. What was the old value? That means what was the old summary? RTTS, right? For that we give 1 minus alpha weightage. Okay, so RTT new value is 1 minus alpha into RTT smooth, that means this is old value, plus alpha into current one, RTTM. Don't worry, we try to understand it very slowly. This is the formula for new RTTS, that is depending on old RTTS and RTTM. RTTM is nothing but the current measurement. So if I show some numerical, you can easily understand. Okay, let's start with one numerical problem. Now we'll see how to calculate this RTT smooth. Okay, initially, so RTT smooth will be nothing, we don't know anything about this one, because we don't know history, right, or summary. After first measurement, that means we send a packet, then you get acknowledgement, right? That is called first measurement. So this duration is nothing but RTTM, first time. Similarly we do so many times, right? So in the in the duration of, okay, start. Hello. Now we'll see how to calculate this RTT smooth. So initially your RTT smooth will be nothing, we don't know anything about that. Slowly we learn it. How we learn is, so we'll see after first measurement, that means we are going to get first acknowledgement when, after sending the first packet. When you send the first packet, if you assume that, let's say, there is acknowledgement, then this duration is RTT measurement. Okay, which is given in the problem. So 5, assume that everything is seconds. So after 5 seconds you get acknowledgement, then how you are going to change your RTT smooth? See, simply RTT smooth is nothing but this value, because you have only one value. When you have only one value, simply take that as current value. Okay, that means currently I have only one information, that itself is nothing but my, I can say data. RTT smooth is now 5. So these two are initializations, I can say. Now onwards we are going to change our RTT smooth based on previous value, because now we have previous value and new value. How we are going to do, we'll see. At this moment, second packet, let's say you are sending. When you send second packet, you get acknowledgement, right? That acknowledgement came after 7 seconds, correct? This one. Then I can say that the second time RTT measure is what? 7. Now we are going to calculate RTT smooth for second time. For second time, RTT smooth is 1 minus alpha into RTT smooth. What is this one? Old value. What was that? 5. Plus alpha into RTT of new measurement. Okay. So for every new measurement from now onwards, we are going to compute new RTT smooth. Sir, what is alpha? Alpha is called, history. Otherwise, I can say how much weightage you are giving to old data and new data, right? You typically alpha value will be 1 by 8, but generally that will be given in the exam. Don't remember it. Okay, alpha will be some value in between 0 to 1, I can say. Now assume that alpha is 1 by 8 and we try to calculate RTT smooth 1 by 1. In the early morning, when you don't have any data, RTT smooth is nothing. After first measurement, that means you get first RTT measurement after first acknowledgement, that is 5, then fix it to 5 second time, first time. Now second time we will see formula RTT smooth at second time equal to 1 minus alpha. Here alpha is 1 by 8. 1 minus 1 by 8 is 7 by 8 into round trip times smooth, old one. What is old one? 5 plus alpha into 1 by 8 into RTT new measurement. What is the new measurement now? 7. If you simplify it, it will be, see, 7 5 is a 35. 35 plus 7 1 is 7, right? 42 by 8. 42 by 8 is nothing but 8 5 is a 40. Then 20, 8 to the 16 and 5.25. If you simplify, you get 5.25. Okay, let me write 5.25. So here we are calculating RTT smooth. Initially it is 5. The second value is RTT smooth is 5.25. After that, this incident comes. One more packet you send eventually and you get acknowledgement after 3 seconds. This time we have to change ourselves because traffic is reduced now. Then this RTT new smooth is 1 minus alpha into, that means 7 by 8 into old value. What is that? 5.25 plus 1 by 8 into RTT measurement. What is the new RTT measurement? 3, right? Take here. So that would be 7 into 5.25. Let's simplify it. 525 into 7. 7 5 is 35. 3 7 to the 14 17. 1 7 5 is 35 36. It would be 36.75 plus 3 by 8. If you simplify it, it would be 39.75 by 8. Let's do again simplification. 3975 by 8. So 8 4 is 32. 7 77. 8 9 is 72. 5 55. 8 5 is 40, 8 6 is 48, then 7 70, then you get 70, so something around that is enough for us. So finally I can say that 39 will become 4.96 because after 2 point there is a point, right? So if you can simplify, right? So that would be 4.96 approximately. Okay, so let's take 4.96 as the next value, which will be 4.96. remember, now we are going to have 10. For 10, we are going to calculate RTT smooth again. What is the formula for new smooth? What is 7 by 8 into old smooth? 4.96. That means we are giving more weightage to old value and less weightage to new value. That is what generally we do. 1 by 8 into 10. So if you do that, 4.96 into 7. 4.96 into 7. 7 6 is 42. 4. 7 9 is 63. 67. 6. 7 4 is 28, 34. It would be 34.72 plus this 10 by 8. It would be 44.72 by 8. That if I simplify, it would be 8 5 is a 40. Then 4 47. 8 5 is a 40. Then 4 7 72, I think 5.59. okay, 8 5 is a 40, you get 4 47, then 8 5 is a 40 again, then you get 7 72, 8 9 is 5.59. in that way we get new smooth, which is 5.59. okay, this is the way we calculate RTT smooth. But RTT smooth is not directly retransmission timeout. Our final goal is calculating retransmission timeout, we know that, but we are going to use this round trip time for that calculation. But exactly we don't use it, we are going to use some more parameters, we will see that, don't worry. Finally you realized how to calculate round trip time smooth. okay, now we'll see RTT delay. We are going to use the delay also into the calculations. So in hello, so far we have seen RTT calculation, right? RTT smooth, but final goal, you know, right, that is calculating retransmission timeout. So in retransmission timeout we are going to use RTT smooth, and one more thing is RTT delay. This is called deviation. okay, so RTT deviation is also going to be one of the component in your RTO. How to compute RTT deviation and what is that, I will tell you. RTT deviation is nothing but what is your past record of RTT and what is the current record which is going to be calculated by RTT measurement. okay, that means your new round trip time says that there is a 30-minute delay, the old summary says that there is a 10-minute delay, then the difference between these two, 10 minutes and 30 minutes, which is 20 minutes, is going to be RTT delay. So this RTT delay is also going to be one of the component in RTO. We will see that. Before that, we'll see how to tune RTT delay, how to learn. That means this is also going to be dynamic like RTT smooth. How you learned RTT smooth, in the same way we are going to learn RTT delay. How you see, initially we say no value, we don't know anything about RTT delay, how much there is a difference. Next we see after first measurement we are going to initialize your RTT delay to RTT measurement by 2. Example, your initial RTT measurement is 5, that means first packet's acknowledgement arrived after 5 minutes, then RTT delay is going to be 5 by 2, which is nothing but 2.5 seconds. So far it is, let's say, good, right? We are understanding. Now after every new measurement we are going to change our RTT delay. How? We are going to give one more parameter, I mean we are going to take one more parameter beta, so that is going to, you know, calculate this RTT delay. Usually beta will be 1 by 4, but we can, you know, take anything, so that will be given in the exam, but that designers will fix it, okay, based on the experiences. So that's why don't guess anything at this moment. Let's fix beta value 1 by 4. Now your formula is RTTD equal to current deviation. What we are expecting is 1 minus beta into old deviation plus beta into this current deviation. This is current deviation, you see, RTT smooth minus RTTM. okay, so you will understand by example. Let me take one example. So RTT delay I am calculating after second measurement. Let's say new measurement came, that is new acknowledgement came, that is after 10 seconds. So this time first we calculate, because your RTT deviation depends on RTT smooth. For that we have to calculate RTT smooth. Let me calculate RTT smooth first. What is RTT smooth values? Initial RTT smooth is we don't know, but after the first measurement your RTT smooth is 5, correct? Now we are at second measurement, okay, after second ACK. What is the formula after second ACK? If you see, first we have to compute RTT smooth after second ACK. So formula for RTT smooth is 7 by 8 of old RTTS. What is that? 5 plus, after getting this acknowledgement, so RTT measurement is 10, right? That means 1 by 8 of 10 weightage. So first we have to compute RTT smooth, then after that RTT deviation. It would become 35 plus 10, 45 by 8. 45 by 8 is nothing but 8 5 is a 40, then you get 5, 8 6 is a 48, 25, 8 2 is so 5.625. So RTT smooth is 5.625, remember it. Okay, now we are computing RTT delay or deviation. The deviation in RTT is formula for that, you know, 3 by 4th of previous RTT delay. What is RTT deviation? What is that? See here, we have computed already that, right? RTT previous deviation is 2.5 seconds. 2.5 plus 1 by 4 into the difference between previous RTT deviation, what is that? 2.5, sorry, previous RTTS, what is that? 5.625 minus current RTT measurement 10. Okay, see, we know this one, 3 by 4 into old RTT deviation plus 1 by 4 into RTT smooth minus RTT measurement. So RTT smooth is what currently? 5.625 after getting this 10, acknowledgement for second packet. So what is RTT measurement for second packet? 10. So if you simplify it, you get 3 by 4 into 2.5 plus 1 by 4 into 10 minus 0, 5.625. If you do, you get 4.375. Okay, so if I simplify it, it would become 7.5 plus 4.375 by 4. That would become 7.5000, 4.375. Okay, we can ignore this 0. So 5, 7, 8, 11.875 by 4. If you simplify it, 4 2s are 8, 38, 4 9s are 36, 27, 4 6s are 24, right? So 35, 4 8s are 30, so something 2.968, right? That is enough, 2.96. Let me write RTT deviation as 2.96. Now we will see for 15. So when you are seeing at 15, what happens, we'll see. First RTT smooth. RTT smooth after 15 is, what is old one? 7 by 8 into this one, right? 5.625 plus 1 by 8 into RTT measurement 15. So if you do that, you are going to get RTT smooth. So 5.625 into 7. 7 5 is 35, 3 7 to the 14, 17, 1, 7 6 is 42, 43, 4, 7 5 is 35, 39. It would be 39.375 plus 15 by 8. It would become 39 plus 15, 54.375 by 8. If you simplify it, you get 8 6 is 48. So 6 63, 8 7 is 56, 7 77, 8 9 is 72, 5 55, 8 6 is 48, so something around 4 6.79. Okay, I can take it as 6.8 or 6.79, not a problem. So finally RTT smooth is 6.79, remember it. Okay, now RTT delay or deviation. RTT deviation is again same formula, 3 by 4th of old value. What was old value? 2.96 plus 1 by 4th of new value. What is the new value? The new value is nothing but RTT deviation. How to compute? RTT smooth minus RTT measurement. What is the current RTT smooth? 6.79. What is the RTT measurement at this moment? 15. So 15 minus 6.79. We have to take absolute value. Then we have to simplify. In that way, we have to continue to find out the RTT deviation. This is about finding the RTT deviation. Let me summarize. Initially, your RTT deviation is simply RTT measurement by 2. First time. Once you get the first RTT measurement, then you divide by 2. Then you get 2.5 seconds. After that, the formula is 1 minus beta into RTT deviation plus beta into RTT smooth minus RTT measurement for every new measurement. Whenever a new measurement comes, at that time, what is your RTT smooth? Compute RTT smooth with that new measurement, and after that subtract that RTT smooth minus this RTTM. Okay, so that is what we are doing. In that way, if you continue, you are going to get RTT deviation every time. Okay, now we will see RTO time. Okay, how we fix RTO, that is our final thing, correct? So RTO is nothing but your RTT smooth. Remember, this is a formula. RTT otherwise RTO equal to your RTT smooth at any point of time plus 4 into the delay. Okay, so RTT deviation, we use RTT deviation here. This is the final answer. Okay, so we'll see one numerical example and we try to compute RTO based on this RTT smooth and RTT. Okay, now we'll see a small problem. You send, let's say, SYN packet. Okay, this is sender, this is receiver. When you send SYN packet, after 1.5 seconds, let's say you got acknowledgement, SYN plus ACK, whatever it is, but it is acknowledgement, right? Now the question is, what is the retransmission time, RTO? Okay, how to fix it? Initially, let's say RTO is something 10 seconds. Sir, how you know that it is 10 seconds? It is given. Okay, somehow they fix it. Initially, we don't have any idea how to keep, right? So we fix something, RTO equal 10 seconds. Now we have to find out the current, after this measurement, a new measurement came, right? After that, we have to update RTO. How to update RTO, we'll see. First step, RTT smooth. Okay, to find out RTT smooth, you should know RTT measurement. What is the current RTT measurement? 1.5 seconds, right? This is first measurement. Whenever this is the first measurement, then RTT smooth, if you see the formula, it is nothing but exactly equal to RTT measurement. That's why 1.5 seconds. Now I calculated RTT smooth. Now we have to compute, RTT deviation. Did you remember RTT deviation? For our RTT deviation, first time we don't know, that means before starting the things, but after getting the first measurement, RTT deviation is very simply your RTT measurement by 2, correct? This is initialization, I can say 1.5 by 2, 0.75. This is about RTT deviation. Now we have to compute RTO, right? What is the formula for RTO after getting RTT deviation and RTT smooth? Simply the formula is RTT smooth, which is 1.5 seconds. I'm writing the formula first. RTT smooth plus 4 into RTT deviation. Generally this is the formula. It would be 1.5 plus 4 into RTT deviation, which is 0.75, which would be 1.5 plus 3, right? It would be 4.5. In that way we fix RTO. Now one more measurement comes. We'll see one more time. If second measure, this is first measurement, right? What if second measurement comes after this one? Again you sent a packet, let's say, then you got another measurement. So that delay, let's say, that is also known as RTT measurement, which is new RTT measurement. Let's say that is something very big number, let's say 7 seconds. Then what are you going to do? How you are going to compute RTO this time? First, step number 1, compute RTT smooth. RTT smooth is 7 by 8 of old RTT. What is that RTT? Old RTT 1.5 seconds plus 1 by 8 of new RTT measurement, right? So 1 by 8 into 7. This is the formula. It would be 1.5 into 7. It would be 10.5, correct? Plus 7 by 8. It would be 17.5 by 8. That is nothing but, I think, 2.8 to the 16. You get 15. 8 ones are 8, then 75, something around. So 8 to the 16, 15, 8 ones are 8, then 7, 70, 8 8 is 64, so on. 2.18. Let's remember it as 2.18. Now I got RTT smooth 2.18, right? Something. So let's see one more time. RTT smooth is 7 by 8 of previous RTT smooth, which is 1.5, plus 1 by 8 of your new measurement 7. It would be 10.5 plus 7, 17.5 by 8. Then 8 to the 16, you get 15, 8 ones are 8, then 75, right? 8 to the 16, 1, 15, 8 ones are 8, then 7. So you get 2.18 around. Remember it, 2.18. Now RTT deviation. RTT deviation formula is what? RTT deviation is old RTT into beta. What is beta? Sorry, 1 minus beta, 3 by 4 into old RTT deviation. What is the old RTT deviation? 0.75 plus 1 by 4 into this difference between RTT smooth minus RTT measurement. What is RTT smooth? RTT smooth is 2.18 minus RTT measurement is what? Current measurement is 7 seconds. 7 minus 2.18, it would be 5.82. Okay, so 0.75 into 3, 2. It's a simplification, that's it. 2.25 by 4 plus 5.82 by 4. If you simplify, it would be 5 plus 2, 7. something 8.07 you get by 4. It would be 4 to around 2 you get 2.01 I can say. So RTT deviation is 2. Then what is the new retransmission timeout? RTO equal to RTT smooth 2.18, formula is RTT smooth plus 4 into RTT deviation. That is nothing but RTT smooth is how much? The current RTT smooth is 2.18 plus 4 into RTT deviation. RTT deviation you see here we have computed. What is that? It is around I think this one 2.25 plus 5.82 by 4, right? So you got something 8.07 by 4, 2.07. Then it would be 2.18 plus 8.04 something. It would be 10.22. In that way we have to compute. There may be some mistakes in my computations, so you just correct them. Okay, don't worry about them. You know the procedure, that is enough. So something I got 10.22 this time for RTO, right? RTT smooth plus 4 into RTT deviation. So 2.18 is RTT smooth, 4 into 2.01 is RTT deviation. You get 10.22 this time. In that way we keep on fixing the RTO time. Okay, this is about RTO. So far we assume that we get acknowledgements in the right time. That means this is what you assumed. You send a packet and you keep a timer. Let's say timer is at this moment, see RTO 4.74 seconds. Then within 2 seconds let's say you got the packet back, right? Then we calculate this round trip time, RTT measure, right? So based on that we compute new RTO. Everything is fine. But what if this packet, otherwise what if you don't get acknowledgement within the RTO time? That we did not discuss so far. Okay, we will see that story now. What is the problem with that model is, we see, send a packet, let's say P1, and you wait for RTO time 4.74, but you did not get. Generally what is the rule? We use timer only to retransmit, correct? So whenever timer times out, then we have to retransmit the packet number 1. Now see the situation. Let's say I don't know, but one of the acknowledgement of P1 came after some time. Okay, this is ACK for P1. Now here question arises, is this acknowledgement is because of new transmission or old transmission? There are two cases. Maybe your acknowledgement got delayed for the first packet and it is arriving now. Second one, maybe the first acknowledgement is gone, first packet itself is gone, so this acknowledgement is for new packet. So because we don't, network is not transparent, we don't know each and every step what is happening. So that's why here we have a dilemma. When we have a dilemma, so what, sir? Forget about the dilemma. Why we have to get confusion? Simply you take RTT measurement as whatever it is, here to here. When you take RTT measurement as here to here, then you are doing mistake. You might do a mistake because this may be wrong estimation, isn't it? Maybe this is the acknowledgement for this packet. Then your calculations all will go wrong, correct? You are learning something, right? Using RTT measurement, RTTS, what are you doing? We are estimating the transmission time for the next packet. But if you wrongly take the data, then that estimations will get affected. That's why don't take the wrong data. So I want to say that this is the wrong data. We don't know whether it is related to this one or this one. That's why keep quiet. For that we use Kahn's algorithm. So what Kahn said is, whenever you have a retransmission like this, then the acknowledgement comes, right, eventually. For that don't consider that. That means don't calculate anything, keep quiet, take the old RTO, that's it. Okay, that means don't take don't do the calculation with this kind of acknowledgements. Again you start calculations only after starting new packet. Eventually you will be sending new packet, right? Once you get acknowledgement, we will send new packet. Then when you send a new packet, for that packet if you get the acknowledgement in the right time, for that onwards we start the new calculations. So for what to do, we will see. What we do is, for this one we simply do like this. Okay, now I am explaining you Kahn's algorithm plus exponential backup clearly. Example, initially you thought RTO is 4.7. You kept a timer for 4.74 seconds. But what happened? You did not get the acknowledgement. Now this is the point. My question is, when you don't get the acknowledgement, what you have to do? We have to definitely retransmit the packet. We do that. Fine. So what about calculations? No calculation, because if you get the acknowledgement, at least we have to do the calculations. We know that for every acknowledgement we do the calculations. At this moment, no calculations. Correct? Now question, sir. My question is, when you send a packet, we have to again start the timer, right? Yes, we have to start the new timer. But what should be the duration? For previous packet 4.74, because we had a data. Are you going to use same RTO? No. We are going to use a method called exponential backup. That means when you send a packet, if it is lost, that means if you don't get acknowledgement within RTO time, then we are going to double the RTO time. Okay, blindly this time timer should be, RTO should be 4.74 into 2 into 4.74. remember it, that would be, I think, 9.48. remember. So now we are going to wait for 9.48 seconds for the acknowledgement. Okay, now assume that, let's say, acknowledgement has come here. Sir, what if this acknowledgement won't come in this duration? It comes after 9.48 seconds. What I told you, recall. If it won't come in the right time, then we do the retransmission again. Same packet P1, and RTO will be double again. 9.48 into 2, 18.96. in that way we continue. Okay, now see the second case. What is that? Let's say really acknowledgement after some point of time came correctly, that means before RTO time, like this example. Okay, so assume that, let's say, after starting the timer 5 seconds it came. Okay, 5 seconds. Now we have to do the calculations, right? But now that is what I said, don't do the calculations here. Why? That is what Kahn's algorithm says, because there is a confusion. This acknowledgement represents this packet or this packet. That receiver sent this packet, this acknowledgement, when he received this or this. If you don't have clarity, then if you take this data, all your calculation will become wrong. That's why Kahn says simply, there is a dilemma, right? Don't do calculations, keep quiet. That means when this acknowledgement arrives here, no calculations, keep quiet. Then when to start new calculations, I will tell you. Sir, when you get the acknowledgement, what you are going to do generally? Yes, I sent a packet, I got the acknowledgement, then I have to start new packet. Here you will be starting new packet. Agree? When you start new packet, then we are going to start timer again. What should be RTO for that? RTO again 9.48. Okay, because we doubled it, that will be fixed now. Start. So we will send P2. When you send P2, you get acknowledgement back, right? When you get now new acknowledgement for P2 correctly before 9.48 seconds, then we will be calculating RTO for that. Okay, so here no RTO, but here we calculate RTO. Okay, now I will take one clear example and I take the data and I show what we have to do. Okay, let me take one example. Now we'll see one numerical problem. See, this is a story. Initially your RTD measurement is 2.50, but that doesn't matter. RTD smooth is 1.625. Then we calculated RTD delay, which is 0.78. After that we calculated RTO. You can cross check. So when you have RTD measurement, RTD smooth, we can compute RTD delay, after that RTO, right? We have formulas. So see the remaining story. You sent a packet. Then what is RTO? 4.74. That means at this moment, this is the point where these are the values. Now since RTO is 4.74, retransmission timer is 4.74 seconds, then we will be waiting for 4.74. But you did not get any acknowledgement. See, acknowledgements are coming from receiver, but you did not get any acknowledgement. First acknowledgement you got here. Okay, second acknowledgement you got here. Now when you get acknowledgement, before that you see the story. Did it arrive before your timer times out? No. So here time is timing out here, correct? 4.74 only here. Then what is the activity we are doing? We are going to retransmit the packet. That's why we send P1 again. Agree? But when you send a packet, we have to restart the timer, correct? What should be the timer value here? Okay, should I take 4.74? No, we have to double it. That is what. So here I can say there will be a timer, correct? So here the timer is RTO equal to 4.74 into 2, 9.48. Remember it. Then slowly we wait for 9.48 seconds. If within 9.48 seconds, if you don't get acknowledgement for the packet P1, we transmit again. But at that time RTO will become double, 9.48 into 2. That is called exponential backoff. But what happened, you see, we got the acknowledgement here. After how much time? Let's say something 5 or 6. Okay. But what is our RTO time? 9.48. This 6 seconds is less than 9.48, right? So within the time period it came. But don't take this ACK as a new ACK, because so this is already, it is a confused ACK. With this ACK we don't do any calculations. Here no calculations for RTO. Okay, now we simply, sir, then what you do here, when you get a ACK after timeout, then we are going to send new packet P2. Definitely we have to send P2, right? When you send P2, then sir, RTO, what we have to fix again? Here RTO will be 9.48. remember it. Now you are going to get ACK, correct? But before 9.48 seconds it arrived, you see, you started here sending P2, within 4 seconds you got it. That means what? This is the right acknowledgement. How to detect whether it is right or not? Simple. Before retransmission, if timer times out, if your packet comes, that means ACK packet comes, that means we have to do the calculations now. This is the point where we are going to do the calculations. Let's begin. First point, what is RTT measure? RTT measure, you see, where did you send P2? Here. Where did you get it? Acknowledgement, 4 seconds. So after 4 seconds. Next, what is RTT smooth? That is to be calculated. What is the formula for RTT smooth? Formula for RTT smooth is 1 minus alpha, that means 7 by 8 into old RTT smooth, correct? What is old RTT smooth? This one, the latest one, 1.625 plus 1 by 8 into current measurement. What is the current measurement? 4 seconds. So this is the first time we are doing the calculation. Okay, for this acknowledgement we did not do. That is the only thing. That is called Kahn's algorithm. Okay, Kahn simply says that for acknowledgement of this kind of confused status, don't do anything. Okay, so here it would be 7 by 8 into 1.625 plus 1 by 8. If you simplify, you get, I think, something 1.625 into 7. 7 5 is 35, 3, 7 2 is 14, 17, 7 6 is 42, 43, 4, 7 is 11.375. Okay, so 11.375 plus 4 by 8, it would be 11.375. Okay, 15.375 by 8. If I simplify, 15.375 by 8 is 8 1 is 8, 7 73, 8 9 is 72, 1 16, 8 2 is 16, 115, 1.92. Okay, let's remember it as 1.92 RTT smooth. Next, RTT deviation. RTT deviation equal to 1 minus beta, that means 3 by 4 into previous RTT deviation. What was that? 0.75. After that we did not do any calculations, correct? Plus 1 by 4 into the RTT measurement minus RTT smooth. That is mod of, what is RTT smooth? 1.92 minus RTT measurement. What is the new measurement? 4 seconds. So it would be 3 by 4 into 0.78 plus 1 by 4 into 4 minus 1.92, it would be 2.08. Okay, now if you see, this will be 2.783 234, I think. That means 2.34 plus 2.08 by 4, it would be 4.42 by 4. If I simplify, it would be 1. I think 10 around you get. So let's say 1.1. Finally RTTD is 1.1. Let's compute RTO this time. RTO equal to simply RTT smooth plus 4 into deviation. What is the deviation? 1.1. Okay, let's take it. RTT smooth is 1.92 plus 4 into 1.1. If you simplify, you get 1.92 plus something 4.4. If you simplify this one, you get, I think, something around 6.36. Okay, so this is about your RTO. Understand? This is the way we calculate retransmission timers. Okay.